Hello and welcome. We'll begin shortly. We do have more participants starting to trickle in, so we'll start 2 minutes after the hour. Hello and welcome everybody to the webinar on data-driven watershed management for Canada's fastest growing cities. My name is Christelle Valentine and I'm the Director of Marketing for Hydromet. I will be your moderator today. Before introducing our guest presenter, I'd like to cover a few housekeeping items. The presentation will run approximately 30 minutes, and at the end of the presentation, we will cover questions and answers. This Q&A session will be led by Kevin Martin, who is the Senior Marketing Manager with Aquatic Informatics. Throughout the presentation, we encourage viewers to ask questions. You can do so by using the questions widget in the GoToWebinar panel as shown on the screen. Now, I'd like to introduce our guest speaker. I am pleased to introduce Grant Wilkinson. Grant has worked in the water resources field for other conservation authorities and for private engineering consulting firms since 2012. Today, he leads the Toronto and Region Conservation Authority, also known as TRCA. Here, he leads the hydrometric program. In this role, he ensures continued acquisition of high-quality data to support all business units within TRCA. He also assists with numerous projects that improve the safety of their dams, channels, and dikes. I will now turn the presentation over to Grant.
Hi, everyone. Can everyone hear me?
Yes.
All right, perfect. Yeah, so I'm Grant Wilkinson. I'm the project manager for Flood Infrastructure and Hydrometrics at the TRCA. And I'm just going to talk about our hydrometric program and our flood response. So just a brief outline of what I'm going to be covering. I'm just going to quickly introduce what the TRCA is and what our hydrometric program does, how we install and maintain our gauges, a quick overview of Enviroscada to get our real-time data to our database, how we respond to flood events, and quickly go over our data review, corrections, and gradings, and our stage discharge rating curve development. And then I'll talk about what we want to do next. So quickly about the TRCA. TRCAs or conservation authorities were established in Ontario in 1946 under the Conservation Authorities Act, and they were established to ensure the conservation, restoration, and responsible management of hydrological features through programs that balance human, environmental, and economic needs. The main objectives were to ensure that Ontario's rivers, lakes, and streams were properly safeguarded, managed, and restored. We were to protect, manage, and restore Ontario's woodlands, wetlands, and natural habitats. Develop and maintain programs that protect life and property from natural hazards such as flooding and erosion, and to provide opportunities for the public to enjoy, learn from, and respect Ontario's natural environment. In response to Hurricane Hazel, the province of Ontario amended the Conservation Authorities Act to enable a conservation authority to acquire lands and develop plans for flood control and water conservation. And in 1959, the Plan for Flood Control and Water Conservation was finalized. The property acquisition that primarily focused on flood vulnerable properties in like valleys and similar areas. For control structures, conservation authorities were allowed to build dams and channels to help reduce flooding, flood hazards. And land use planning, that's a big one. Conservation authorities are now involved in helping developers prevent further development within a floodplain, basically preventing people from putting themselves in harm's way. So the TRCA's area of jurisdiction, we are within the Great Lakes Basin. We have 9 major watersheds in the area, and our jurisdiction is about 2,506 square kilometers on land and 961 square kilometers of water. Our roles and responsibilities. TRCA is mandated to operate a flood forecasting and warning program. This is to understand flooding risk in the GTA, the Greater Toronto Area, and improve the flood forecasting and warning program in the areas. We monitor the watershed and weather conditions and operate the flood forecasting system. We issue flood messages when one is needed. We will operate the Conservation Authority owned dams and flood control structures, and we'll provide advice to municipalities in the event of a flood. And throughout the floods, we'll maintain communications with municipalities and other affected agencies. So TRCA's hydrometric program, as part of TRCA's flood forecasting program, we run the hydrometric program that operates and collects data such as precipitation data, meteorological data, water level data at streams and in dams, and discharge data. And this program includes both real-time stations and standalone stations. Standalone stations, as the name suggests, don't have the capability to send data remotely to a server. We can upgrade these stations, but that costs more money. And if you want to have a look at our real-time network, we have 2 websites. One is currently under development, but they're listed right there, trcagauging.ca and beta trcagauging.ca. For our precipitation gauges, we have 39 different locations across the jurisdiction, 17 of which are operated year-round, and 25 of which are real-time when they are in operation. And we have 14 standalone precipitation gauges. This gauge data is collected between April and December if they are the 3-season gauges. And like I said, it's year-round if it's the 4-season gauges. So for an example of a 4-season gauge, we have the Pluvio rain gauge with the Sutron 9210 logger up in the right-hand corner. And for a 3-season, we've got a tipping bucket rain gauges with, most of them also have 9210s, but this one has an HSPA link logger. Our water level gauges, we collect water level at 49 locations, and we continually add more when the appetite is developed. 22 of these gauges are real-time and 27 of them are standalone. And at TRCA, we mostly use 3 different types of sensors. We have pressure transducers, bubblers, and ultrasonic sensors. Most gauges include a rating curve to calculate discharge, but some are water level only. The water level only ones are typically in a flood vulnerable area where we only care about what the water level is at that point in time. So up here we have a pressure transducer that's going to be put into the stilling well. Here we have a Sutron 9210 with a bubbler system that runs into the creek. And here we have an ultrasonic sensor mounted to a bridge. So our typical real-time station setup is we need a power source because we need to power the equipment and the modems. That runs into the data logger along with the field sensor, whether it's a rain gauge or a water level sensor. And that gets logged into the Sutron, typically a 9210. And in a few cases, we have the HSPA link loggers. And that goes to our cellular modem. We use a static IP address so that the data logger can be pulled remotely. And then that data gets sent out to our database. So here we are installing a new water level gauge next to a creek. So for precipitation gauges, we maintain them monthly. We'll check them to make sure that they're functioning properly, make sure all the wires are connected where they should be, make sure that the buckets are tipping as they're supposed to. And we clean out the funnels wherever you get a lot of debris buildup, whether it's bird poop or leaf debris or seeds or whatever happens to be in the area. And then for our Oppluvio calibrations, we use weights to make sure that the weigh mechanism is functioning properly. We make sure the precipitation gauges are calibrated twice a year, or if an unusually heavy downpour happens that could alter the calibration, we'd go out and check it at that point. And additionally, when we're looking at the data, if anything looks off, we'll do a calibration check on that gauge at that point to make sure it's functioning properly. So our water level gauge maintenance, these gauges are also visited monthly to download the data, especially if it's a standalone gauge. Check the level against a reference benchmark to make sure that what the gauge is reading is accurate. We'll review the data in the field to see if anything looks bad and if any more work needs to be done to improve the gauge. Annual maintenance will also include cleaning the sensor. So we'd take some cleaning liquids and scrub it off to make sure that the pressure plate is working properly, make sure there's no debris clogging any bubbler lines. Flush any stilling wells to make sure there's no sediments plugging up the well affecting the level data. We'll survey and fix any broken reference points that we use to check the level, and any other maintenance that will need to be done, such as fixing pinched orifice tubes or removing beaver dams as we are here. So Enviroscada is what we use to get data from the field to our database. It's an out-of-the-box solution provided by AQUARIUS. And all we have to do is tell it, basically name the data logger, an analog point, and those combine to make the gauge. There's scheduled polling of gauges across the network every 4 minutes. And we use the Aquatic Informatics professional service to set up and complete the initial configuration of Enviroscada. And what that does is we have a SCADA DLL file to decode the Sutron SSP logs, so that way the data is translated into our database correctly. So just a quick flow chart of what that looks like. We have the Sutron out in the field. Every 5 minutes if it's a rain gauge, 15 minutes if it's a stream gauge, taking measurements. Enviroscada comes in and pulls the data, gets the data from the log. That gets pushed into AQUARIUS time series, which is where we will perform all the QA/QC checks, store the data, and then publish it. And then from there, it goes to AQUARIUS web portal, which will send our gauge alarms and calculate data statistics such as peak water levels and total rain. And from time series, it also gets pushed to our flood monitoring website, which allows a public data view and gives us some data visualization and reporting. So real-time flood monitoring. Precipitation gauges are set to alarm to flood duty officers, dam operators, and flood infrastructure and hydrometric staff when the precipitation rate is 5 millimeters in 5 minutes. So because the gauges log every 5 minutes, if any of those values are above 5 millimeters, we'll get a message saying that there's a lot of rain happening. Our water level gauges have established alarm thresholds where when the water level reaches that defined elevation, the gauge sends the alarm to the same people, the flood duty officers, dam operators, and flood infrastructure and hydrometric staff. And the AQUARIUS web portal alarms are sent to us via email and text message, and they are also visible on the gauging website. Just an example of what the gauging website looks like. That's just the map view. Whenever the gauge alarms, these nice green colors that indicate nothing is wrong will turn yellow and red when they're under alarm. So what are our alarm responses? First, what happens typically is a precipitation alarm will trigger, and that just alerts the flood duty officers, the dam operators, and the hydrometric staff that something may be occurring that will require a response. And at this point, our actions will include to continually monitor the weather and our gauges to see if the event is continuing. And we may potentially issue a flood message if it has not been issued as of yet. When a stream gauge alarms, what happens here is the alarm gets sent to the same people, and that says that the flooding may be imminent or is already occurring at the gauge location. The new actions that happen here is we may have to respond to public inquiries and media requests about the flood, provide emergency response support to the affected municipalities, whether that's telling the municipalities what areas are going to be affected and help them decide what to do. And we may have to dispatch staff to the affected areas for flood event monitoring and documentation, and in some cases, even what actions they should take, give them advice on that. When a dam alarm is triggered, that alerts the FDOs, dam operators, and hydrometric staff that a dam operation may be necessary. And these new responses could include operate a dam if the water level and rate of rise indicates that that has to happen. And if it's a really bad event, we may have to activate the emergency response plan for the dam in question. And here you can see TRCA's dams that have gauges associated with them and what their alarm thresholds are. Low alarm is basically just letting the dam operators know that you should be at the dam now, and high alarm means operations are imminent. So some recent notable events for the TRCA. I'm just going to cover July 20th, 2017, and the most recent one, January 11th, 2020. So what happened on July 20th, 2017? Just a thunderstorm brought about 40 millimeters of rain within 2 hours. This triggered 6 precipitation gauges and 4 stream gauges. Most of the impact of this event was felt in the lower Dawn region, right by the waterfront of Lake Ontario. So what happened around 10 o'clock on that morning, we got a brickworks precipitation alarm, and that basically put the flood duty officers on high alert that things were happening. The Don River at Todmorden gauge alarm triggered, saying that the water level is rising above the first alarm threshold and that the water level is still rising. Then very quickly, the high alarm triggered. And then the high alarm triggered, which means that flooding is actively occurring, and roads will need to be closed down. Then a bit later, the Don River downstream at our Dundas gauge triggered, and it continued to rise to its high alarm, saying that the roads next to the river are flooding as well. So just a brief map of the area. So this is the Don River. It flows downstream this way, so north to south. Up here is our Don River at Todmorden stream gauge. Right here we have our Brickworks precipitation gauge. And way down here we have our Don at Dundas gauge. So when the alarms were triggering, this is what was happening in reality. The river water was pouring out over the railroad tracks and onto the road and causing some issues for the traffic in the area. And then down at Dundas, same thing, the water was coming out of the channel and onto the highway, causing a closure of a couple lanes of the Don Valley Parkway. So how did we respond? Like I said, the precipitation gauge alarms alerted the FDOs that riverine flooding could be occurring soon. The stream gauge alerted the FDOs that the flood was incoming. And in response, their flood duty officer contacted Toronto Transportation and Toronto Police Services, as well as Metrolinx, who was the owner of the flooded railway line, and Evergreen Brickworks, who owned a property in the flood vulnerable area. The flooding caused a closure of the Bayview extension at Brickworks and one lane of the Don Valley Parkway. So there was significant issues for the traffic in the area. All right, recently, January 11th, this was a widespread long duration event. It brought total precipitation amounts between 70 and 95.5 millimeters across the watershed. Smaller water courses with smaller drainage areas did not reach critical water levels because it's such a long drawn out event that this very flashy systems didn't respond very well, or not very well, very intensely. They stayed relatively low. However, the larger watersheds, they responded fairly quickly. The ground was frozen at the time, so not a lot of infiltration was occurring. And for a long period of time, because of all those tributaries feeding in, bringing in a lot of water to the larger water courses. So how did we respond? We knew this was happening. We had a pretty good weather forecast leading up to it. So we went out and checked the river ice conditions in advance to make sure that that wasn't going to complicate any areas and cause any jamming that may cause localized flooding. Doing so, there's minimal ice present, which was a good thing. Our stream gauge alarms alerted the FDOs to where the flooding was occurring, and our FDO contacted to warn of the flooding the town of Caledon, Toronto Transportation, Toronto Police Services, GO Transit, and Metrolinx, which had the railway line flooded again. Evergreen Brickworks again, because they're in that flood vulnerable area. The Durham and Toronto's emergency operations centers, contacted them. Pickering Fire and the Toronto Zoo, which is built along the floodplain of the Rouge River. TRCA staff are also dispatched to assess the flood conditions at suspected and known flooded areas. And both of TRCA's large flood control dams, the Clairville Dam and the G. Ross Lord Dam, reached their operational thresholds and required operations. So for example, G. Ross Lord Dam, this is what the water level is normally. Here we have the low-level gate building where we hoist up the gates to open and close the dam. Normally it's high and dry, but near peak level, we were only a couple meters from reaching the building itself. And then late Sunday night, the event started Friday, and then late Sunday night, the water level finally started falling, and you can see it start to drop in this picture. So our operations were conducted on the 12th and 13th of January. What we did was we were forced to lower the low-level gates to 24 inches. The maximum opening of those gates is 6 feet. So we were a third of the way there. We did that to stabilize the reservoir to make sure that the dam wouldn't overtop, causing further issues. We used our downstream hydrometric stations to confirm that the operations conducted to stabilize the reservoir would not cause flooding downstream, which would prevent the activation of our emergency response plan. The maximum allowable reservoir level in the dam is 181.36 meters above sea level. And we were at 180.068 meters above sea level, and that's storing 3.3 million cubic meters. That's over 2 sky domes full, or Rogers Center full of water. Downstream, the operations, you can see this is our first immediate downstream gauge in red. The operations conducted bumped up the water level quite significantly, but we were still 0.8 meters or 80 centimeters below the level that would cause an alarm to be triggered. And downstream even further, to the Don River at Todmorden, the operations raised the level not nearly as significantly, and we were still 60 centimeters or around 2 feet below a level that would cause flooding. Now at Todmorden, that event already caused some flooding, but we want to make sure we're not causing any additional flooding when we operate. The Clairville Dam. Clairville Dam has 5 radial gates, numbered 54321 as you get further away from the control building. The gate in the middle gate number 3 always remains open. Under normal conditions, no water's flowing over it because the concrete spillway is slightly higher than the other 4 gates. So we always keep that one open just to maintain a base flow. The operations there, the rising water levels required the closing operations of gates 2 and 4, and that was to lower the discharge rate coming from the dam to prevent downstream watercourse flooding. The further the reservoir level rises, though, we will have to reopen those gates to stabilize it to protect the dam from failure. And as the night went on, you can see the Clairville Dam reservoir level rising. So we were forced to close the gates here to restrict the flow out. And then once we got up to 166.73, we start opening gates 1, 2, 4, and 5 to stabilize the reservoir to keep it from failing. The effect of that operation downstream, we can see at the Humber River at Old Mill, had a brief spike in precipitation causing some rising water levels, but then the dam operations really impacted and raised the water level quite significantly downstream. So post-event, TRCA had to continue monitoring and inspecting our flood control infrastructure and perform any maintenance as required. such as any debris or tree removal. This event brought a lot of debris into our infrastructure, so it required a lot of clean out. Erosion risk management staff were deployed to reported erosion sites to monitor the impact and perform any emergency works where required. Our hydrometric staff were deployed to collect high water marks at 12 locations in our jurisdiction, basically to mark how high the water got so that they could be surveyed later for event documentation and reporting. Our gauges were inspected to assess if any damage occurred, such as any flooded gauges or any in-stream sensors getting removed or damaged in any way. Luckily, we only had one, a bubbler line for our Black Creek out of lines gauge got ripped out during the event, and we had to repair it. And luckily, it's a pretty cheap and easy repair to do. And then we had to continue our communication with our municipal partners regarding the event and how they were doing. So once we get all that data into our Aquarius time series, we will review it and check for any anomalies. We'll look at the sensor, look for any sensor or logger errors that can cause any issues. We'll look for any sensor drift and apply any corrections. You can see an example of some sensor drift corrections here. The green is the raw data. The blue data is how we've corrected it. And we assess the overall data quality and make notes if any problems are encountered and if any more field maintenance is required, such as removing any beaver dams or cleaning any sensors. And then we'll add some grades and some qualifiers to the data when necessary. So on the left here, we can see some precipitation data. The blue data is a tipping bucket gauge, and the red is a op pluvio gauge. And you can see how the tipping bucket gauge is affected by snow and ice. There's some snow happening here, so we'll grade that. The tipping bucket gauge is poor and give a reason why in the qualifier. And same is happening here. You can see a lot of snow melting into the rain gauge here. And the four season gauge getting precipitation, but the tipping bucket gauge not. So we'll add qualifiers such as if when the data is poor, we'll say it's poor and add qualifiers to why it's poor. When there's icing occurring in the channels, we'll also grade that as poor and give a reason why, and we'll let the end user decide what to do with the data from there. So we'll give you the data, give any notes as to what the data was, to why the data is good or bad, and let the end user decide if they want to include that data in their studies. Our discharge data, our stage discharge rating curves are developed for stream gauges that require the discharge data. So that's most of them. We like to take our stage discharge measurements at various different stages using a flow tracker when it's safe to get into the water. And when it's not safe to be in the water, we use an acoustic Doppler current profiler or river surveyor to collect those measurements. We require typically 10 unique stage discharge measurements to have a complete rating curve. Complete is in quotations because, in our opinion, it's never complete. If you get a good event that will extend your rating curve, we'll get it, we'll take the measurement and improve the curve from there. Our rating curves are constantly being checked and verified, and when a significant control shift is detected, we'll have to develop a new curve and apply it to the correct period of time. So here you can see that we are starting to build a new curve. All the old ones don't line up with the current new measurements. An obvious control shift has occurred, so we're building a new curve to reflect the new conditions of the site. So who uses TRCA data? We receive data requests from internal staff for hydrologic modeling and calibration of floodplain mapping. We get requests from academics, municipalities, as well as private engineering consultants. And you can request the data using our TRCA gauging website. And what's next for the TRCA hydrometric program? Step 1, building resiliency of our existing sites, whether that's improving our power supply by either having the electricity hook up right into the gauge building itself, or getting more powerful solar panels to last the cold, dark winter months here, as well as putting in redundant sensors where we have some gauges that may be susceptible to icing or other issues, just to make sure that we always have good water level data when we need it. And with real-time station network expansion, we are hoping to convert a lot of our standalone gauges to real-time gauges. But to do that, we need to do some tests on other data loggers to not be so power hungry. So because we have a lot of sites that don't get a lot of sun because they're in very shaded areas, as well as nowhere near an area to get electricity hooked right up to it. So we want to get some lower power data loggers and see how they function with our system. And now we're on to questions.
Grant, thank you so much for sharing your story and a very engaging presentation on data-driven watershed management. We'll now turn it over to Kevin Martin from Aquatic Informatics, who will lead the question and answer session.
Thanks, Christelle. And yeah, before we jump to questions, I just wanted to echo that thanks for our speaker, Grant, and the TRCA for making the time to support this initiative and share a bit about their program and learnings today. I actually personally found it fascinating as I grew up in the Greater Toronto area before moving out west, and lots of familiar scenes there for me. In fact, that 2 sky domes full of water analogy was quite impactful. So I know we're already kind of short on time, so we'll be quick here with a few of these questions. A number of folks asked about getting a copy of the presentation. Yes, everyone that's registered, whether they made it or not today, will get a copy of the recording as soon as we get that out, possibly as early as tomorrow. All right, so without further ado, let's jump in. Grant, we had one question right at the start that you might have answered later, but just to make sure, how frequently are you verifying the stage discharge relationships for the stream gauges that transmit both water level and discharge data?
So is this question about how often we check our curves?
Because how often you verify the relationship, the stage discharge relationship?
Oh, that's ongoing, like constantly. Any station that we have a rating curve for, we will constantly be checking it. Basically, whenever we get a good rain event, we hit as many gauges with rating curves as we can. And if the points line up on the curve, beautiful. If they don't, then we got to go back to those gauges and rebuild a curve or make sure that wasn't just a bad measurement that we took. So every gauge with the rating curve is always being checked whenever we get the conditions that allow us to do that.
Bit of a labor of love that never really ends, sounds like.
Yes, that's why a curve is never complete.
Got it. There goes the explanation. Another one here, it's pretty interesting. Have you thought about utilizing new technologies that integrate weather forecasting and machine learning of real-time data to create predictive flood alerting and warning instead of reactive flood alerts?
Yeah, our FDOs are involved in that. There's the flood early warning system that they're getting involved in, and we're testing with us, as well as there's radar, like gauge assisted radar as well, that we're looking into as well. So that's all coming down the pipe.
Yeah, awesome. And maybe on that same kind of line of thought around alerting, we had a couple questions around alarms notifications. One person asked, what does the web portal alarm notification website look like versus the website? I think the one that maybe you showed at the start with the gauges. Just curious what the difference is there, I guess.
The website is our public publicly facing interface, I guess, for the web portal alarms. I typically don't see that. I just see the results of it happening on my phone, just getting alarms to my email and text message alarms. So
got it.
Typically,
And
I only see the messages.
yeah, no, and that, I mean, that's where the real value is for you as an operator. And is on the same note, is there any kind of public service announcement related to flooding events that are triggered by this system, either text messages or radio announcements, anything to the public?
On our website, we have those the flood we shows whether we're in a flood warning or watch. I'll just, if I can pop over to show you what our website looks like.
Well, maybe we could probably follow up with a screenshot or something and then follow up just in the interest of time. But
yeah, we issue flood messages, but they typically go to municipalities and anyone who's signed up.
Got it.
To
so there's more
it.
of a folks that want to be in the know. It's not like what people might expect for a public service announcement, like sirens going off and folks being alarmed.
And on our Twitter, we'll always post if a flood message is occurring. So if you follow us on Twitter, you'll see a flood message when it pops up.
Right. Oh well, tons of questions popping in now. So maybe we'll cap off with this last looking forward one and maybe call it there. And just as a note on that, anyone that we didn't get to, we'll definitely get a follow up to you either from the hydromet team or the aquatic from mixed team. But maybe just to look to the future, Grant. Someone asked, how will climate change and extreme precipitation affect flood prevention and prediction in the future?
Sorry, could you repeat that?
Sure. How will climate change, which I guess leads to extreme precipitation, affect flood prevention and prediction?
Well, I'm not sure if I can answer how it will
it's more of a, I guess it's more asking you to repeat. Yeah.
It's climate change is throwing all of the 100-year storms and all those statistics out the window. So it's
Fair.
It's a very difficult question to answer. It's just what's probably going to happen is there's going to be more intense storms causing more issues, especially in highly developed areas without a whole lot of areas for infiltration, like a lot of flashy systems.
No one has the complete answer. You need a crystal ball to get there. But it sounds like you and the TRCA are well on top of it in terms of monitoring, because you can't manage it, you can't see. That does make me wonder, though. You mentioned, just on a final note, just because it popped into my own head, you mentioned the gauging dashboard is available to the public, and it sounds like the web portal information that's there, triggering alarms, is sort of kept internal. Is there any plans to open that data up to the public as well, to sort of further inform that?
With receiving gauging alarms?
Well, just, yeah, with what's made available in web portal, because it can be made public. I was just curious if you have any plans to open that up. A number of our customers, in fact, have public-facing AQUARIUS web portals, as well as other data they share on different websites. Just curious if that was something you were exploring at TRCA.
Not that I'm aware of. Our website is going to be reading directly from AQUARIUS time series, and I think the website is the way that we're going.
Got it.
Everything.
That makes sense. Yeah, given that you already have a website that you can plug AQUARIUS time series into, then maybe that kind of settles that. So that's great. Okay, again, I do realize we've gone a bit over time here. So on behalf of the teams at Aquatic Informatics and at Hydromet, I'd just like to thank everyone for spending some time with us this morning. And again, big thanks to you, Grant, and the TRCA for sharing your expertise with us today.
All right, thank you.
All right, cheers. Take care, everyone, and we'll see you next time.
Bye.